All right. I did remember to hit record. That's good. If you don't see me start recording, just holler at me because someone else will be sad. Um, right. We're cruising right along. Hopefully everything went well. Chapters 1 and 2. I didn't bother posting a quiz for chapters 1 and 2. I'll do it for the other chapters, but not very interesting here. So not too concerned about that. Again, Project Zero, that was essentially our practice. Can we get this workflow to work? Again, I'm a big fan of using GitHub. I think it's a great tool. We can use it for free. That's cool. And I think putting code in Canvas is stupid. Again, you're welcome to quote me on that. It's okay. No one else will care about my opinion, so it's all right. We'll use that. So our grader has access to repositories that get created using the GitHub Classroom tool. So that makes life easy. So you'll have access to it. I'll have access to it, and the grader will have access to it. So you can actually get some points for it. Is that right? Should work out pretty well here as we go. And then later on, I never fixed my project number. Shoot. You'll have the option to do the later project with a group, sort of like a trial run, see if your group members are any good, essentially. I can set up shared access to one of those repositories. I'll just add your other group mates to it. And we'll do the same thing with the final project. I can just add shared access there for you. That works out pretty well for everybody. So because the free tier for GitHub, I believe you can only have 4 contributors. So if you have a group of 4, you can't add me or the grader, and then that's pretty sad. But I can make them because I've got the account with better access. So should work out pretty well. I think maybe for the graphical program, that one's a little bit trickier to do with groups, just because if you're messing around with your graphical user interface and someone else monkeys around with it, it can get a little awkward pretty quick. But for sure, our database project will offer the option to do it in groups. Again, I would recommend it, but it's going to be up to you folks for that one. But the final project for sure does need to be done in groups. And again, I think I mentioned if your group fires you because you didn't do any of the work, you failed the class, right? Because the final project is worth 40% of the score. And if you don't have a group project to turn in and present, you can't get points for a group project, right? All right. So again, get to know somebody. That was a good exercise for the first project. Should be a lot of fun. And then ideally you're done by the 4th because we've had a month to work on it. I know Thanksgiving break, you probably do some other things here and there, but maybe you can put a little bit of time into it. If you're not done by the 4th, you have a whole other week to get it done, but you do have final exams that week, and some profs think you need to memorize a bunch of crap so you can pass a test instead of actually like applying the things you've learned and having a product. Which I mean, we've got the benefit of that. It's kind of easy to show a product at the end of a software class. Like, oh hey, I learned some software things. Here's my software. So I get we got that pretty easy. It's a little harder to do for a history class of like, here's the history stuff I learned. I don't know how you apply that stuff, but again, I'd love for people to be done by the 4th. So get together with your team, finish up everything, polish everything you need to do, get ready to go. If you got questions, let me know. Happy I can hop on and help debug stuff. But ideally by then we're done. If not, you got a little extra time. It should be good. So I know it seems silly. We're already talking about the end of the semester, but just kind of keep this in mind with the plan. So every 2 weeks here, we'll have a project. So starting tonight, we'll start project 1. It'll be due in 2 weeks, and we'll go over the solution to project 1 in class. There's no solution for project 0, right? I think I did that one last week for you, right? Like I did my little intro. Did I? Okay, good. I've got a lot of classes and things kind of blur together, and I've been doing classes for years now. So if it if I'm talking about something like it already happened and it didn't actually already happen, just holler at me because I've done that before. So, yeah, so when project 1 is due on 9/18, I'm going to go over the solution first thing in class. Again, I'll show you how I would approach solving it. It goes relatively quickly. Again, I've been doing it for 20 years, so don't feel bad that I do it faster than you. Again, that's to be expected, right? That's just normal. When you got 20 years experience, things should go faster for you. That's all. So for project 1, I can't take it late. So we've got 2 weeks. Please plan ahead. If you get it all done in the first week, great. If you get some of it done, great. If you want to cram on 9/18 in the morning and spend all day getting it done, you can still get points for it. But that strategy doesn't work well as projects get bigger and more complicated, right? It works well, 150, 200, your projects were pretty small, right? They didn't do a whole lot of interesting things. You could probably get it done in one sitting if you tried hard enough. Did anyone cram in and get their projects done for 150 or 200, like the couple hours before it was due? One person, at least admitting it. Okay, I get it. That's all right. Um, let's try to not do that here. If you need to, that's fine. That's what happens here. But Thursdays, Um, I'm at home doing stuff with the kids, and then I drive here. So if you run into an issue in like the 3 hours before it's due, it's really hard because I'm trying to do dinner at home before I leave for me to help you. Those 3 hours before it's due. So I've got much more time earlier in the week to help you out. Happy to hop on screen shares, and Zoom sessions are really quick. I can do them on the weekends if we need to. I'm always up crazy late because after my kids go to bed, it's quiet and I can get work done. So if you're hanging out in the Discord server, I'm usually online till 2, 3 in the morning most days. Again, that's just my schedule. I hate mornings. If I can sleep in till noon, it's a good day. The kids don't always let that happen, but again, that's the schedule I like, and um, you got a pretty nice schedule. I don't have to be anywhere at 8 in the morning teaching, so it's pretty handy. Um, all right, so I'll fix the project number. Again, every 2 weeks, we'll get one done. We'll go over it, and we'll just kind of keep up with that flow. It's a 3 credit class. Did I mention that? So the expectation is you got about 2 hours of work outside of class for every hour in class. So this class is about a 9 hour a week commitment. So just keep that in your back pocket, sort of, do some pencil napkin math. Am I putting in about 9 hours this week? Some weeks are less, some weeks might be more. It shouldn't be more than 9. If it's turning into more than 9, let me know. We'll have a conversation, see what's going on here, how we can help you be more effective in your study time. But again, somewhere in that range, 6 to 9 is probably a good number of hours. And we've got 3 hours of lecture, almost 3 hours of lecture, 2.5 by the time we take our breaks of lecture time, another 2.5, 3, 4 hours of doing some homework, doing some work, actually doing the readings, doing the quizzes. That sort of thing will be helpful. And again, we know how learning works. You'll be more successful to retain the information if you space it out. If you sit down and do all 9 hours in one sitting, you're probably not going to remember much of it the next day. Right? But if you do a little bit and a little bit and a little bit and a little bit repetition, you'll get it more. And just like a math class, when it comes to programming, you never get to forget stuff you learned already. It only ever builds on itself. So calculus is really just a mean trick to make sure you're good at algebra, right? And trigonometry, right? You had to remember all that trig stuff. So same idea. We'll learn stuff and we'll keep on using it here on out. So tonight, we don't go too far into anything new and interesting. You should have done exceptions before. You should have done testing before. You should have done methods before. You should have done control statements before. We're just looking at how to do that in Java, and then we'll apply it to the next project. Classes work similarly in Java, very similar. The object-oriented principles still all apply, right? Do you learn your 3 fancy words for principles of object-oriented programming? Anybody with the three fancy words? Inheritance, encapsulation. What do you got? Polymorphism. I like it. Yeah. So again, same ideas apply. We'll look at it. Nice job. You get a bonus point, but they don't actually matter. Sorry. But so yeah, we'll get into that. We'll look at using arrays. It'll be a lot of fun. Um, I'd like to use arrays in the first project. I don't think that's going to be asking too much of you folks because you should have done arrays already in C++, but we'll just do a little deeper dive on the 11th. Um, but we'll look at arrays and array lists, which are very similar to vectors. It's a nice little shortcut here. Very flexible. And I'm not fond of arrays that are fixed in size because they're annoying to work with. That's all. Right? I like to be able to add and subtract from my arrays. So I like vectors. I like array lists. They just make life easier. Yes, they're ever so slightly less efficient. We're not doing anything a billion times over, so it probably doesn't matter, right? And actually, for project one, you have got the option to do a billion times, so maybe you might want to optimize it here. We'll look at that and have a little bit of fun with it, but you don't need to. Like we'll stop it probably less than a billion iterations. So, okay, sound okay? You got a plan? We'll move forward. Again, I'm talking, I'm coding. Just holler at me. If you raise your hand, I might not see it because I'm usually staring at my screen to make sure I'm not making typos like I do all the time here. My style's a little different. We'll get with the flow of it. It's okay. A couple of you folks have had the displeasure of having me more than once, and so they signed up for another one of my classes. So it worked out for some people. So we fire up IntelliJ here. I still haven't installed the new combined version here, but if I didn't tell you again already, I recommend you turn off their trial license. You don't want it to do the extra things and all the fancy AI stuff that they're offering. At this point, it's you probably know enough for it to be decently helpful, but it's going to do too much for you. And then it's hard to cite your sources if it like generates half your code without you even like lifting a finger with sort of the I don't know AI generated IntelliSense stuff. It's like, oh, you're trying to write this method here. Here it is. Like, hold off on that. Again, we're going through the steps here. There's good places to use it. We'll get into where we want to use it, but for now, the bulk of the effort should be ours, right? We can use it for specific pieces here, and it's hard to be specific if it's just on all the time, right? So it'll just make life easier for you to not. So, um, excuse me, I got to get some coffee soon. I had my whole pot here. I've got a big growler. That's an insulated one I got for Christmas a couple of years ago, and it holds an entire pot of coffee or a growler full of beer, depending if it's morning or night. Although I do drink coffee all night long too. But um, so when you make your project, make sure it's in your repository folder. Okay? If it goes in the repository folder, Git can do its job and watch the files change, make the commits, make those snapshots, and then sync with the cloud. So my course repository, this is the public one. I'm just going to make a new project every week. For you, you'll have a new repository every project because that's cleaner, a little easier. And then I can make sure if you do happen to change the files for the next project, it doesn't look like you tried to change your previous project's files when it was, just a couple things happened here. So everything is timestamped in Git. Did I show you guys that? So I can see when you submit stuff. So if we look at, I can just go to the course repository. It shows the timestamp of when things were changed, which is pretty handy here. So you can go to this commit list here. There's only been 2 commits. It's not very interesting here. And you can see when those commits were made. Here it says, oh, it was last week. And if I hover over it, it shows me 8:07 p.m. Right, Eastern Daylight Time. Right. So you can make your commits. I can see they were made on time here. No worries. Right. That's how we track all that here. So if you're changing your files after the due date, I'm just going to go back into history and look at the version that was there before the due date. Won't be too hard as long as there is one there, right? If you don't make any commits until after the due date, like 6 p.m., the day it's due, we're going to have a problem. Again, for project 0, nope, it's okay. Don't sweat it. We're just practicing. But project 1 and on, when we've got actual stuff to do, right? This is where the timestamp matters here. You'll also have to give me the link to Canvas because unfortunately the two don't talk to each other. And then Canvas knows, hey, you have to go and grade it. That's all. All right, so we can go from there. Excuse me. So we'll call this one week 2. Drop it in my repository folder. Don't check the create Git repository box. Again, putting Git inside of Git confuses Git, and then we all get confused. It's fixable. It just takes some extra steps. So just don't check the box, and you'll be fine here. I like the sample code. Great. I'll go ahead and create it. Now, in Java, right, the name of our class has to match the name of the file. So this is main.java. This is the public class main. And so now it matches. If you're doing it yourself, you can add your own files here if you want. You can add one here. We'll call it week2.java. And it automatically says, oh, hey, this should be public class week2. Because I named the file week2, it's making the public class in that file for me. It's just a helpful thing. We don't have to do it by hand. So I'll use week2 instead of main just to be different this time here. And then there was that other boilerplate code that you don't need to memorize. It's okay. But done a lot of Java. I use IntelliJ a lot, and it's got a bunch of shortcuts. So it's public static void main string array args. Or if you type PSVM for public static void main and hit tab, it generates the rest for you. Yeah.
What is it?
So this is a public method of this public class. It's a static method, so it's defined once at the class level. You can't make more instances of it. It's a void method. It returns nothing. Its name is main, and it takes a string array called arguments. So you can pass arguments to a program when you call it. We don't need to use these arguments, but it's possible to pass them. That's the default path. So just like int main was the entry point for any of our C++ programs, public static void main is the entry point for a Java application. So if you want to run a Java class, or the bytecode that gets compiled, the Java virtual machine says, hey, let me go find that main method, the main function, and run it. And that's where it knows to go look. So if you try and run a class that doesn't have a main method, it won't run. We can write classes that don't have main methods. Again, we'll get there in a little while, a couple chapters. They won't have main methods because they're not runnable. It's just class code that we're going to use in the rest of our code. Right?
What besides public static void? What could it be?
Nothing. It's got to look exactly like this for it to run. Yep.
Like with a string and all.
Yep. It's got to match. Pretty sure. I don't think I've ever tried to remove those. Pretty sure it needs to be there. Yeah.
If every Java program needs that, why isn't it like implemented?
It's a great question. And that's things other languages have gone to, and like they will implicitly include that for you. Java's not there yet. So you got to be explicit and say, here's my starting point. Um, just a sad thing, because we just have to do it. Yeah. All right. So control statements: if, else, right? If something's true, run this. If it's not true, run that. They work the exact same way here. Um, but let's go through and get some user input going. I forget where exactly it showed this in the book. My apologies. I skimmed through the chapters. Honestly, I didn't read the whole chapter. It was terribly dull. I've been doing Java for 20 years now, so reading the next iteration of a textbook is really dull. So I skimmed through it. Uh, I know what the sections are essentially here. So, but I forget where it was. And if we want to get input from the user, there's a couple ways to do it here. The easiest way that I found to do it is to use one of their classes that's built into their library here. So we're going to go import java.util.scanner. So this says, go to the Java utilities library, give me the class name scanner. Okay. You don't need to memorize it, just copy paste it. Again, I've been doing a lot. I'm lucky I remember the right words here. Most of the time I just have to go Google it because that's okay. You Google a lot of things as a developer. No shame in that. So we're going to use this scanner class. So using the scanner class, we can go say, give me user input now. So in C++ land, it was the cin was our standard input. In Java land, we'll have a system in as our standard input. In Python, we just said input, and life was good because Python's amazing. So to get user input, then I need a scanner. You can call it anything you want, right? So this is the instance of scanner. We're saying it's a type of scanner. The name of the class here matches. Now my variable name for it. The first textbook I started learning from years and years and years ago always called it keyboard. I like that. You can call it anything you want. Again, it's just a variable name. So scanner, I'm going to call mine keyboard here equals a new scanner. So use this new keyword to say I want a new instance of the scanner class. And one of the things you have to give the scanner class is one of these. There's a whole bunch of different options here. Essentially, an input stream is what we want to use. Where is it getting the input from? Okay. For us, it's system.in. And then our semicolon. Not all that interesting here. Again, we're just going to copy paste this a lot anytime we want user input from the console, which until we get to JavaFX and doing graphical user interface applications, we're stuck with console input and output. Life is sad. Eventually, we'll get some pretty applications we can click on with buttons and pictures. That's much more entertaining, I promise. But we'll get there. Right, so I've got my scanner. Again, I'm calling it keyboard. You can call it anything you want here. Some people like scanner with a lowercase s. I don't know. I prefer keyboard. Again, I've been doing it so long, and that's what it was always called, and it's comfortable for me. So to get some input, I need to go have a place to save it. Right? If I want some string input here, I need a string to store that input in. So I want a string, and let's call this one name. Now I can just declare it, or I can declare and initialize at the same time. So if I declare it later, I can go assign it a value or initialize it here. I'll say, hey, I want it to be keyboard dot. Now, the scanner class has a bunch of things that it can do here. Most of the time, like 99% of the time, I'm only ever going to use next line because that's the easiest thing for me to do. So next line will get the user's input, the entire line of it, and give it back to me as a string. So the return type here is string. Now you'll notice it's got other options like next float, next int, next long, these sorts of, I can get other types. I would strongly discourage you from using it because scanner is a little bit stupid. So if you ask for a float or a double or an integer and you type in a number and hit enter, scanner is actually very smart. It says, oh, you asked for a number, please only take the text that is numeric. So if I ask for a number like 42 and I hit 42 and enter, remember the enter key is actually, there's a character for it that's stored in strings, like the \n, the new line. So scanner says, oh, okay, you only want the number part. You entered 42 return. I'll give you the 42, and it leaves the return there because you didn't want that. You only wanted numbers. The next time you go ask for something like a string, it says, give me the string that was entered. It's like, oh, I have one. You have a new line character. Here's your string. When you didn't want that enter, you wanted the next thing they entered in. So it gets really obnoxious. And then you essentially have to go just read the new line character off of the buffer, the input, and it's really annoying. Okay, so I will never use these next floats, next ints. A lot of code you get online uses them. It's probably more efficient. but then you have to remember to go read off if you're doing strings here. And I don't remember that most often. And then I run my program and it doesn't work and I have to spend 2 minutes debugging it. Like, why is it skipping the next prompt here before I remember, oh, I did a dumb thing. Okay, that's all. So we'll just use next line. Basically all the time here. That's the easiest one here. Yeah.
I already get that syntax, like, why does it look like that?
So for keyboard dot, which part?
Like, scanner keyboard, maybe.
So scanner is the type. So we're saying I want an instance of scanner here. The variable name's keyboard. We're assigning it, and the new saying make a new instance. You can have 50 different instances of scanner because it can also read files and it can work with other input streams and it can work with a bunch of other things. You might have more than one of them at a time.
Is that a class?
Yeah, it's a class in the utility library.
That's all you create about an instance of the class?
Yeah, a new keyword makes a new instance of the class. It loads it in memory for us.
Like the type you said is the class itself.
Yeah, the type is the class. Yep. All right, so I've got a name, right? But if I just hit run, it just pops out here and sits in a second. Maybe. Usually it's fast after the first one. All right. Sure, this is fine. Don't worry about those things. Sure, we could add this if we wanted here to avoid it, but it's not worth it. It looks like it's running, but it's just kind of sitting here doing nothing. It's waiting for input, right? We told it, go get the next line. So it's sitting and waiting for the next line. So if I type something in, like Eric, then my program can go and finish. Because we didn't prompt, we didn't output anything, right? So first we have to output. So to output, right, that's the system.out.println line. Did we do that last week, right? So and the shortcut, if you don't want to type all of that or copy paste it here, is SOUT and hit tab. And I love my shortcuts. I'm going to use them all the time because I'm very lazy here. So we'll say enter your name, right? Now, print line will go down a line at the end here. So maybe a colon here might be a little bit silly. Again, that's just a style preference. I don't particularly care one way or the other. So now when it runs, it says enter your name, and I can enter my name on the line below it here. I get Eric. And not super very interesting, but then we can output, hi Eric, hi, and name. No, sorry, concatenate here. Hi plus name. There we go. And now the computer's talking to me. Hello, very exciting. So your name, Eric, this is great. Now, if you're coming from C++, next line will get you the entire string. It's like a get line. Right? It's not CN where it would stop when you have spaces. So next line will give us everything. So if I type in my full name here, we'll get my full name back out, which is nice. So if you want to break on spaces, we can go do that other ways. So there's other ways to do that here with our strings. So now if we want a numerical input here, right? So we'll have maybe an int for age here. Let's just do all in one line. So let's prompt then say enter your age here. And in age then will equal to convert something from a string to something else. Right? If I'm only ever using next line, I'm only ever getting strings, we have to convert them. To do the conversions, we use the Java class here. So if I want an integer, it's capital I integer. So there's a Java class for integer that has all the methods to do cool stuff. So one of those cool things it can do is parse int. I don't know why they came up with parse, but they use the word parse. It sounds fancy here. So parse is a string to try and turn it into an integer. I'd like convert, but it's okay. We're going to call it parse because that's what fine folks at Java said. And what do we want to do here? What do we want to turn into an integer? Well, we want to turn our keyboard next line, next line into an integer. So I'm wrapping it, right? It doesn't have to happen all in one line. You could declare age, get your keyboard input as a string, and then hand that string to your integer parse int if you like 3 lines. If your boss, when you go out and get a paycheck, says, hey, you have to have, 500 lines of code a day as a productivity metric, which no one intelligent uses lines of code as a productivity metric because it's a terrible metric. I can turn 1 line into 3 really easily. And that's why they don't pay you by line of code, right? Because then everyone would game the system. And you would, okay, let me declare my variable, let me initialize my variable, those sorts of things here. So again, 1 line of code versus separate lines doesn't particularly matter here. When we've declared the variable, we've asked the operating system to hold the space for it, and when we initialize, it actually gets stored in memory. Right? It's holding it, it's waiting for it, but there's nothing there. Then we initialize, we've assigned it its first value, its initial value here, and it has something, we've loaded something in memory. So you have to assign things first, right? So if we try and do something with name before we go and give it a value, we're going to get some weird stuff happening, right? It's not even going to compile for us because it's saying, hey, variable name might not have been initialized. Yeah,
But could we do string name equals keyboard the next line only?
yeah, yeah. Just like we did here, you could do it all in one line if you wanted. So we could have string name. Oh my goodness, where this way here? String name equals keyboard.next line. Okay, so if you like the one line, great. But if you declare it, it won't even let you use it until it notices it's been initialized. So the compiler is checking that for us, which is nice. Like, hey, you called it here, but there's garbage. There's nothing at that memory location. Remember, like in C++, you declare a variable and you get garbage. And then it lets you use garbage, which is really sad. C++ lets you shoot yourself in the foot, right? Java at least is kind, is like, no, dummy, you didn't put anything there yet. There's nothing there to read. Don't read garbage, right? So this doesn't work. Um, can't use till it's been initialized. All right, I'll try and throw a couple comments in every now and then. Again, they can be helpful as much as I hate comments here. Uh, just holler at me if you want them, but sometimes I put weird stuff in, and just looking at the code without listening to me talk about it can be a little confusing because I put weird stuff out there. So I'll try and explain the weird stuff if I can help it. Right, so we convert, right? Integer.parseInt. If you want a double here, like salary, right? That's double, you guessed it, dot parse double. Right, keyboard.next line. Right, so it'll ask for your salary, enter your hourly salary here. At some point, usually in software, you'll have the pleasure of not being an hourly employee, which means you get unlimited overtime, you just don't get paid for it. It's actually kind of sad. But as a salaried employee, there's other benefits and the way scheduling works and things like that. You're supposed to be more flexible, again, depending on where you work and all sorts of fun workplace stuff there. Um, but we'll go with hourly right now. So we got name, we got age, we got salary. And now we should figure out if we can get a car loan. Right? We'll pretend we're the bank here. So I'm sure the bank has a 5 line of code algorithm that decides whether or not it's going to give you a car loan. Honestly, it probably does. It's all based on credit score. But we'll pretend like we're actually doing some real underwriting here and evaluating people. Not that banks do that anymore nowadays. Okay, so we can check. Now I know your age and I know your salary. So hey, first off the bat, if your salary is greater than what do you want to say? Your hourly salary. We'll probably assume people work full time. That might be a bad assumption, but adding in more stuff here is just going to make this more complicated. $21 an hour? Okay, sure. So if your salary is more than $21 an hour, then we can print out you get a loan, right? If it's not more than $21 an hour, right? Else if our salary is maybe if it's more than 18 an hour, and so we do our double ampersands for anding together here in Java. If your age is greater than maybe 25, maybe now you'll also get a loan. Where is it? Oh, I didn't enter anything here. Maybe you get a loan, right? Maybe. Yeah.
18 is less than salary, which is less than 25. Would that work?
So you can't sandwich a variable between numbers here. No, not in Java land. Python lets you do a lot of fun stuff here, a lot of nice shortcuts. So if you start out with Python, you lose some of your fun shortcuts, sadly. So maybe here, if you're old enough here, you're not making great money, but maybe you'll get a loan here. And then otherwise, so if you don't make enough money, you're not old enough here, you get no loan. Right? And control statements, pretty basic. We've done these before here. If, else if, else if, else if, else if, else. It's the mutually exclusive chain. One and only one of those will run. Right? If you have just a bunch of ifs, multiple of them can run if you code it wrong. Right? You might have meant only one of them to run, but it's possible more than one runs if you screwed something up here. So just got to be a little bit careful as we're going here. So there's some basic control statements here. Other fun things we can do here. You can use switches. I am not a fan of switches. I've almost never used them because I just dislike the syntax. And I dislike having to write break and the way that if you don't add a break, it does weird things. So again, I mostly avoid them here, but we can play with one for fun. So maybe we'll switch off of like a little menu here. So we'll print out here. What type of car do you want? Type of car do you want? And then we'll give them a couple options here. We'll make some sort of menu like A, B, C, D, E. Or should we do 1, 2, 3, 4? We can do 1, 2, 3, 4. So what's the first kind of car we should sell? I've got a Bolt. All right, we'll sell a Bolt. Right? What's the next kind of car we should sell?
Lamborghini.
I can't spell Lamborghini. L-A-M, Lamb or
GHI.
G-H-I?
Think so. And I
Okay, that spell checked it, so sure.
um,
Must be. All right, what other kind of car should we sell?
a city.
Civic. All right, easy. We're a used car lot. What else should we sell here? Just one more. F-150. All right, easy. So we've asked them to enter some values here. Now we'll go get some input here. So maybe now do you want to do it as a string or do you want to do it as an integer? Sure. So an int for choice then is integer.parseInt of the keyboard.next line. Again, I'm not typing most of that. I'm typing a couple letters and hitting tab, letting autocomplete work. Looks like I'm typing really fast. I promise I'm not. Although I do type quick. If you want to play Type Racer at some point during break, play you at it. And if you can beat me in Type Racer, you can have some bonus points. I've yet to find someone who can beat me at Type Racer. So we'll see. It's fun. We'll try it later on break. All right, so we got our choice then, and then we want to switch off of choice here. And now when we do a switch here, we've got, why is it yelling at me? There's a joke about your IDEs yelling at you, like as you're going, giving you warnings. Like this one says it's empty because I just started it. Like, slow down, IDE. I'm not that fast. Not as fast as you are. So I say case one, colon. What happens if the choice is a one here? Well, we'll print out, sorry, not print, system out print line. Print line, thank you. So you want a bolt, you picked a bolt, you love the planet. Ha 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 ha. We'll pretend like we don't have to mine for lithium or anything like that, right? The supply chain doesn't matter. I don't know. We'll see. It's sort of a bet, right, with electric vehicles that battery technology will get better as they get more popular, and has gotten better a little bit here. But artificially creating demand to try and push for more innovations, that's an interesting strategy. We'll see. All right, case one, sure, done. Now case two, shift tab, case two. What is this one here? The Lamborghini.
You've got some money.
Just have some money. Sure. All right. And case three. What is this one here? The Civic. A very reasonable car. My wife's first car was a Civic. That thing was great. We drove that thing into the ground and then like 180,000 miles on it, something like that. I think it was sweet. Got from point A to point B. And then F-150, you want to print out here. You probably got to lift something, right? Want a lift kit? Right? I don't know. Sure. And then a default case, right? If we didn't pick one of those, we have a default printout here. We asked for 1 through 4 dummy. Okay, so we give it a try. There's our switch. We're switching on choice. Give it a run. Enter your name, Eric. I enter your age. I'm 38. Salary, you said 21. I got to be more than 21, right, to get my loan. What type of car do we want to buy? Make that a little bit bigger here. Sorry. Bolt. All right, 1. Oh crap. We got everything. We forgot to break keywords. This is why I hate switches. I think they're stupid. So that's okay. So you have to use the break keyword to say, please stop. Okay. So at the end of every case, you have to manually break out of it here. Otherwise, it just keeps running until it finds a break statement, ignoring the other cases. So it doesn't matter that I didn't pick a 2. It didn't find a break yet, so it's just going to keep running code. I don't know who came up with these. They irritate me here. Break. And then break. Now, you don't need a break for default because there can't be code after this. You can't have cases after your default. So there should be no other code for it to fall into. So if you want to add a break for symmetry, go for it. But it's redundant at that point here because it should be the last thing. There's nothing else for it to do here. The scope of our switch statement ends, and we're done with the switch statement there. And make sure we add our breaks here. Come on, Eric, 38. 22, I get my loan, we buy a bolt, and we got a bolt. We left the planet. And when you grow up watching Captain Planet, you feel like you have to do things, right? So they brainwashed me as a kid. Uh, you guys didn't watch Captain Planet, did you?
Yeah.
Yes. All right. Yeah, one. um, all right. So switch statements, if else, works all pretty well here. Now, our logic, right? We did anding here with an and. If we want to do an or, so if you did another or statement, let's do a little validation loop here. So let's keep them in this menu until they've given us something that is good, right? So if we know we're dealing with integers here, I've got my int for choice. Now, the problem with doing it this way is I'm going to have to repeat my menu, right? So what I typically like to do, again, because I'm kind of lazy and I won't have to copy paste this, because a good rule of thumb, anytime you have the same code twice, you should feel bad about yourself. It's a good rule of thumb, I promise. So what we're going to do, we're going to declare choice above the menu, and we're going to make it something that is invalid, because we want to start the validation loop running. Because if it's a valid input, the loop should not run. That's how we get out of the loop, right? Once it's valid, the loop stops running. So we want an invalid value. So we'll say while my choice is less than 1, or with 2 pipes here. The pipe character is such a fun character. That's the shift backslash here. Choice is greater than 4. If any of those is true, then we'll keep on prompting them. Now, I don't need to redeclare choice here. And it's actually yelling me saying, hey, variable choice is already defined. Uh-oh. Right, so we just want to change the value. We just want to assign here. Now, if you like doing your own tabs, you're welcome to do that. Again, you can grab multiple lines and tab them in, shift tab around. Or if you like shortcuts, I have to remember what it is here. It is, it's got a really nice one here. It's not refactor, it's code, reformat code, Control Alt L. I don't know why. So if you like shortcuts, Control Alt L, or just hit reformat, it will fix all that for you, which is really nice. It'll do all your tabs for you, assuming it can find matching curly braces, which is pretty handy. So it'll take care of a lot of that for you. We got lots of tools. You don't have to do lots of manual work here. However you want to do it, it's fine. So we're going to set choice to invalid, and as long as it's invalid, run the loop. So we'll prompt them once here, right? We could add something at the end if you wanted, but then we have to have like another check to say, hey, you did it wrong. Usually just putting the menu up again, people get the hint. Sometimes you have to be really clear, like that was a bad input. Here's the menu again, please try again. That's really just a style preference, right? It's as specific as you want to get here. Um, sometimes you want to design for your grandma to use your program, so you have to be real explicit with your directions to make sure she understands the technology. Other times you can assume your users are relatively savvy. It's up to you. So we use a while loop here. Name, age, salary, type of car. Oh, I'm supposed to do an invalid one. I forgot, sorry. We wanted to make sure it does work, right? Any code we write, we want to test to make sure it does what it's supposed to do. So I'm going to write code and run it, write code and run it. I'm going to do that all the time here. It's a little annoying when you got like 30 different examples going already. So we'll do something invalid like 5, and it just gives us the menu again. Now, if we say like 10 and we spell it here, we crash. So it's a little sad here. This is our stack trace, right? This is the exception that happened. We'll look at how we can handle these in a minute here. But week2.main, line 42. What happened? Integer parse int, number format exception for input string 10. So a number format exception. It's not the best error out there, but hey, the number was in an invalid format here for integer parse int. Probably you can get the picture of what that means, right? If you want to copy paste it, you can go Google it here, right? We can't convert this. TEN is not an integer, right? You got the picture. Okay, so we've got that here happening here. If we want to deal with that, right? One of the other things we we're going to talk about was exceptions, right? I think we had the syllabus link here. We're going to do exceptions, so we'll use a try and catch. Similar to C++, try and except from Python. Do the same idea here for dealing with that exception, right? So if an exception can happen, we need to wrap it in the try block. Now, we probably want to stay inside the while loop. Putting it in the right spot is going to matter here because it's going to go back to where we needed to be here at the end of that try block. So I'm going to put just this little bit here in that try block. I'm going to try. I'm going to move this in here. Again, I like cut and paste, Control X cut, Control V paste. You can drag if you want here. And then with the end of a try, we're going to catch. Now, I know specifically this is a number format exception, right? Number format exception. Well, I like calling it EX. Some people just call it E. Doesn't particularly matter too much here. Yes, I know it's empty. IntelliJ is too fast for me. I'm not quick enough for it. Well, so if we caught an exception, if an exception happened and we managed to catch it, it matched this type here. What do we want to do? Well, we'll tell them, invalid input, right? That's it. So now we've avoided crashing here, which crashing your program is one of the worst things you can do. For some reason, I get weirdly irritated by programs that crash because I feel like the developers were just lazy and they didn't do a good job because they should not crash. We have enough tools nowadays to make them not crash. Yeah.
Why doesn't it crash? Does it go back to the
Yep. So we instead of crashing, the catch runs, and then our program says, "Oh, is choice invalid?" Sure, it's still invalid, right? Because it obviously didn't parse here, so the value must still be 0. We're back to our loop here again. Yep. So again, putting it in the right spot's going to matter here. If we put it on the outside of the while loop, we'd have some problems because we would have caught it, but we're outside the loop, it's not going to run anymore. And just like it was before, we just need to make sure we catch our exceptions in the right spot here as we go. Right, so we've got all that. Let's give it a try. Name 38, 22. All right, let's buy a Lamborghini now here. We must have some money. Let's just do invalid input. I got too excited to buy a Lamborghini. Do people still watch Mr. Beast? Is he still cool, or did he get canceled for being a jerk? So we still don't get an error message because no exception happens with a 5, a 6, a 7. We just stay in the loop here. But now if I type in TEN, I get an invalid input message here. Right? Again, we're not crashing. We're doing a better job handling it here, which is important. Right? Crashing is a big no-no. All right. We'll go back. Maybe we'll buy the Civic here. All right. So all of that, if we wanted, might have, maybe should have been if we were going to get a loan or not. If we weren't going to get a loan, we shouldn't have asked them what car they wanted anyway. Or maybe they could buy the Civic outright. They're not. The used cars are still pretty expensive nowadays. That's with the used car market. Um, but we could maybe buy one of those without a loan, right? Depending on how much you've saved up, but the other one's probably not. All right, so while loops. There's also another kind of loop here that I strongly dislike, again, because of the syntax. It irritates me. Just like I don't like switches, you can do a do loop, which will run once and then repeat possibly if the while condition is true. So while is a pre-test loop. So it's possible that the while loop never runs, because if this is not true, it doesn't run. So if I screwed up and put choice as 1, my loop doesn't run, right? Because I screwed something up, right? Or if we're just using it for validation here, if you ask them first, it might never run. But the do loop will always run once and then possibly continue here. So we can do a do loop. So let's see, we did our cars, and then we ask about an extended warranty, right? Because everyone wants to sell you the extended warranty. That's how dealerships make their money, right? So we'll say do, set of parentheses. At the end of a do loop, you have a while block, right? While what here? So we'll say, how about we have a string for warranty. Now I don't need to declare it, or I'm sorry, I don't need to initialize it. I can declare it here and use it inside the loop here. And then we'll say my warranty does not equal yes. Why is it bad? It's warning me. Okay, I have to initialize it in here as well. Well, it's not a yes, and warranty is not a no. If it's not a yes and it's not a no, if both of those are true, then the whole thing is true and our loop will run. Right? Will repeat itself again.
Shouldn't it be warranty is yes and no?
Well, yes and no are both valid options. So I'm saying here's a valid option and here's a valid option. Right? The loop's job is to make sure I've entered one of the valid options. Right? So the only way to get out of it is if one of them is that, then it's false. And if I'm anding all these together, anytime you've got a false when you're anding, the whole thing is false. If it's false, the loop doesn't run again. Right? So I'll ask him here, do you want an extended warranty? And then we'll set warranty to my keyboard.next line, next line. Right? Now, this reason here. Now, thankfully, it's gotten a little smarter, and IDE is smarter. When I was younger, my crappy IDE I was using because it was free in school was not very good. Didn't have a warning here. at the end of our while loop, you have to have a semicolon because it's attached to a do. I don't know why. I hate it. Right? But whoever decided to write the Java parser decided that's what we had to do here. Um, and it's awful. And this is why the entire reason I never use do loops, because I spent 3 hours trying to debug code because I was missing a semicolon at the end of a while here. And I decided never to use them again because they irritated me.
Oh, sorry. What is the difference between do while and just while?
So do will run it at least once, guaranteed to run once. It might repeat. The while loop might never run. So this is a post-test loop. Tests at the end to see if it will repeat. The while loop tests at the beginning to see if it'll repeat.
So you don't need. Okay.
No, because it's not calling itself. It's just whether or not it should repeat the loop here. We're checking at the end of the code running rather than the start of the code running. Okay, so we'll make sure we sell them the warranty at the end. We should make them feel bad about not getting the extended warranty and shame them on the way out because that's a good sales tactic, right? You definitely want your customers to feel bad when they leave your store. I don't know why people do this. Like, car salesmen are the worst. I'm sorry, if you sell cars, I apologize, but in general, car salesmen are the worst. Just must be a miserable job. Uh, Salary, we'll buy the F-150 this time. Or do we want the extended warranty? How about yes? Do you want an extended warranty? No. Well, crap. Well, so maybe we should tell them, like, hey, probably enter a Y or an N, right? Your users are probably stupid here. So give them what you're expecting here. If we wanted to also take a yes or a no, right, we could add more things in here. We can have more options. We got a couple choices here, but again, let's just go with how about an N here for no. Uh-oh. Did I do it wrong? It's not. Uh-oh. It's telling me string values are not compared using exclamation mark equal sign. We can't use the not equals when you compare strings because a string value in Java is stored in memory somewhere. So the variable actually stores its memory address. It's like a pointer. So the value of warranty is a memory address of where the actual string is stored in memory. So does this string equal another string? Does this memory address equal another memory address? Is not comparing do the strings match. Right? So Java doesn't even, like, it's warning it. It lets us do it, but it doesn't work here. So it's saying you should use equals. There's an equals method here. So we want dot equals here. And equals is even really nice here because it comes with an equals ignore case. So if I wanted a capital Y or a lowercase y, I can just use equals ignore case and my life is a whole lot easier. Right? So let's do this here. So now warranty equals ignore case, and n. Now the problem is this is equals. We didn't do the not equals, so we have to not that and not that. Right? So use the unary not operator. Not true is false, not false is true. Right? We don't use it all that often, but because we don't have a not equals method, we just add the not to the equals method. So if it equals this not, and it equals this not. It's a little bit convoluted here, right? But hopefully you're following, right? If not, holler, it's okay. Let's stop and run it again. See if this works for us here. Oh, look, exit code 130, because I hit stop. It didn't return a 0. I don't know if you noticed before, it was returning zeros. It didn't even show implicitly. I know it says void doesn't return anything. Like in C++, you were supposed to return a 0 at the end if life was good. It doesn't say it returns, but it implicitly does, which is kind of cool. So it's ever so slightly smart. Name, age, salary. Oops. Extended warranty. Let's try it lowercase n. And we got out of our loop. Life is good. So again, validating here. Does it not equal this? And it does not equal that. If we got a bunch of them, we got a bunch of choices here. We'll look at better ways to do it. Again, using an array or array list, life will be a whole lot easier for checking these sorts of things as we go. But for now, we'll get through it. Okay? All right so far? All right, I've been going close to an hour. I wanted to get a coffee. My throat's getting dry. Are we okay to take a break? Take 10 minutes and come back? All right. Sounds good. Let me pause it here. Just remind me to unpause when we're done here. Boom. All right. And we're back. All right. So we are continuing on in our flow control. Let me, my goodness. I'm going to pull up the chapter here real quick. Make sure I'm doing the right thing here. Because we want to get to exceptions, methods, and testing as well. My bookshelf. Yay, ebooks. Um, Come on. My library. Java programming. All right, so what chapters is this one here? Excuse me, I think it was just one big chapter, right? Oh, 3 through 6. Okay, 3, 4, 5, and 6. So a couple chapters. Here, there we go. So control statements. Oh, primitive data type. We did some data types already. Control statements, methods, handling exceptions, testing, and debugging here. Okay. So let's look at methods, right? I think we can move on to methods. Here, is there anything else interesting? Boolean, if else, switch, loops, break and continue. Again, I hate break and continue, especially in loops. They work the same way they do in other languages. I don't think we need to spend a lot of time there. So look at methods. Methods are pretty fun here because we get to define something outside of main, right? We're writing a method that can be used other places here. Most of what we're going to do initially will be public methods. We can make them private. So private methods will only be accessible within the class that they're declared in. So we can make private methods and still use them. We can make public methods and use them. It's not going to matter much at this point. Once we get to classes, it'll matter a whole lot more. And there's good object-oriented habits here, and there's bad object-oriented habits with public methods and private methods and things like that. So we'll get there. Not too much time on that today. And then if we want to use the method in main, we're going to make it a static method because I don't need a new instance of week 2 to call the non-static methods. Again, once we get to classes, we'll look at all the non-static stuff because I'll have an instance of a class I can call the methods on that work with its attributes. Okay, but for now, we're just going to do static methods here. So I'll be lazy and these will all be public static. Right? Void if we don't return something or what we're going to return. So how about we return a string here for this one here? And we'll call this one, how about get input here? And maybe we want to be given to this method to run, we need to give it a string. We'll call it prompt. So you give me a prompt, I'll go get the input here and give it back to you. And so it's not very interesting here, but we're going to print out the prompt. And then we're going to, now keyboard only exists within the scope of main. So I can't use that keyboard instance here, keyboard dot, doesn't exist. Right? It's not there. So we can either go make a new instance here, or we could optionally pass in a scanner object that can be used. That gets to be a little bit complicated. And I don't prefer that approach. It's probably the more efficient approach. But again, we're not doing anything a million times, so who cares? Right? It's not the end of the world here. So inside my get input, I'm going to repeat this. I'm just going to copy paste. Feel a little bad I got the same code twice, but it's not the end of the world here. And then we'll go say my string for, I don't know, input is my keyboard.next line, next line, and then we will return the input. Again, no validation, nothing's fancy here. Does it not like about input? Local variable is redundant. We can inline the variable. Oh, look. So this is kind of a helpful hint here, saying you declared it, saved it for a second, and then you returned it right away. You made it redundant. You didn't do anything with it, so why not just do it in line and just return that? Right? Get rid of the whole having a variable thing here. That's one option, right?
Professor.
Yeah.
Sure. Do you have when you are in a function, it's like class. Is it string or prompt? Because prompt.
Prompt is a type of string, so we have to give it a string, right? Because it's going to match on finding a string here for the prompt. Yep, that's our parameter. Yep. Yeah, technically it's a parameter here, right? But when you call it, it's an argument. It doesn't really matter. Everyone calls them arguments almost all the time here, but it's technically different. So again, I don't mind having it stored here and then returned. When our methods get more interesting, you'll be able to put a breakpoint here and see what the value is before we go and give it back. If we just return a keyboard next line, it's really hard to put a breakpoint there and wait to see what was entered and if we do anything with it. But again, this is not very interesting, but it's okay. So now our get input can be a little bit faster now. So instead of saying, hey, enter your name, we have a string for name and keyboard next line is name here, right? We can condense all of that here with name equals get input, enter your name, right? And life is a lot faster for us. Or string name is a get input, right? It saves us one line of code. We don't have to prompt, right? We can do it inline. Look, so we wrote a helper method. And now we can reduce the lines of code here and be more efficient, whatever you want to call it, right? That's just a fun one. There's no validation though, right? It'd be nice if we're doing some sort of validation here. So what if we had like a number range, right? So we want to, we'll make another public static. Now this one is going to return an integer, right? So it's a type of int. So the primitives are all the lowercase ones here. The class of integer also does work. Java does this cool boxing and unboxing thing where if you give it a primitive int, it can turn it into the int class, or if you give an int class, it can turn it into the primitive int. Most of the time, we just don't care. It's not really worth paying any attention to. But most of the time, we'll just use the primitive types. So int, this is a get number within range. Again, method names follow our variable name convention, camel casing. Start with a lowercase letter. Every next word gets a capital letter. So get number within range. So we need prompt, so a string for prompt. And then we need an int for lower bound. We need an int for upper bound. Forward bound. Now, we could go through and put in some comments and have some documentation auto-generate and say which one is inclusive, or we could say lower bound inclusive here to be explicit and upper bound exclusive here. Right? So we're including the lower bound, excluding the upper bound. So if we put it in the variable name, I don't need to have a comment that tells you, hey, you get the lower but not the upper. Right? You know, make your code a little cleaner. Yeah.
What can you set default values?
A default value?
Yeah.
Yeah, we can do those in a minute. So that's the next method we're going to do. Yep. This one's a little long here. We can bump it down a line if you want. Again, Java doesn't care. It's a little ugly, but that's not the end of the world here. So we're going to get a number within range. So again, we need our scanner keyboard. Now, other people, and especially if you go Google things, it'll say you can just do this at the class level and have a static class level variable for scanner keyboard. Sure, you can. I would argue probably 99% of the time having static class level variables is a bad practice. So we're just not going to even entertain that bad practice. And we'll feel a little bad having the same code more than once, but we'll smile knowing we didn't do a bad thing. Right? There's a very specific time and purpose. When you go take a design patterns class, you'll learn about singletons and having single instances of static things. We're not there yet. We don't need to bother about that. Okay. Keep in your back pocket, but just it's probably a no-no. Okay. All right. So our keyboard here, and then we're going to print out our prompt here, and then we'll get an integer input here, right? So an int for my input is a keyboard.nextLine, but now I need to convert that, right? So integer.parseInt of the, oh my goodness, it erased that, keyboard.nextLine, missing my closing parentheses there. Now we can check, right? So while my input is less than the upper bound, or no, I'm sorry, if I want it greater than or equal to the upper bound, because it's excluding the upper bound, right? If that's bad, or if it's too low, my input is less than the lower bound, inclusive, I just want to be less than, I can be equal to, right? While that's the case, we're going to need to prompt them to get more input, right? I don't know what a good default value is here to set it to make sure the loop always runs. I could do something cheesy and be like lower bound -1, because that should always be invalid. But it's also possible they give me the lowest possible integer here, and trying to take one away from that's going to screw things up. So by trying to be clever and cheesy, we could screw things up. Now, why are you trying to get a lower bound inclusive of the largest? Is it largest negative number, or is it the small? Are they larger as you get more negative, or I don't understand math. The one never negative 2 billion, whatever, right? That we can sort an integer. Most negative, furthest from zero. Because you're not getting larger than when you're getting more negative, right? Isn't that
Closest to negative infinity.
closest to negative infinity? There we go.
Trevor, that's a question. You said it's exclusive, so shouldn't it get rid of the equal sign?
So if it does equal this, then it's invalid. So if it's equal or greater, this is the invalid. I need to run my loop again. Right. So if it equals the upper bound, we're excluding it. It doesn't work because I've said, hey, 100 is too high, or whatever it happens to be here. If we just repeat it here, we'll just do the prompt and do our input again here. Eventually, it should work here, and then we can return the input. Now, we can even give them a message like invalid here. Try again if we wanted, right? Or even tell them like must be between. Now, this would have been nice to actually tell them initially here because they might not have known, but that's okay, right? Must be between lower bound inclusive, and we concatenate another string and the upper bound exclusive, right? Give them a prompt. So this could be helpful if we need to do any sort of number validation. Like we've got a loop that did that, right? With our choices here, right? Not having to do this. Now, having a menu string like this as a single string in a prompt, we'd have to do some interesting stuff and add in our own new line characters or start appending things, and that gets a little bit messier. Sometimes it's nice to just have your print lines do your new lines, but I mean, we've got some options. So we can write our own methods to do stuff like that, right? So that's getting a number within range here. Then the next thing we can do is we can add default values, thank you for asking, to our arguments. So we might not need everything to be provided here. So if we want a sensible default, we can have a sensible default. So maybe we have something like a public static double get total price with tax, right? That takes a double for price and a double for tax rate. And we're going to default the tax rate to 0.06. Oh goodness, where did that go? I clicked the wrong thing here. Why is it yelling at me? Did I do it wrong? I did it wrong. That should work. No, maybe it doesn't work. I get confused sometimes. Default arguments. Copilot search, come on. Java does not support them. I really thought one of the later versions of Java added it. I'm really surprised. That's kind of depressing here. Huh. What does Copilot say? Okay, we can use method overloading or varars. Varars is obnoxious. So method overloading is our go-to practice here. Yay, Java. You don't know how modern technology works, apparently. I'm sure it'll get added at some point. That's a pretty common thing. So if you want to have a default here, we don't get to do it this way, which is sad. So we don't get to add a default here. We'll just do our, return total price. Oops, turn price times 1 plus the tax rate here. Or maybe we should do some interesting arithmetic. We should probably check, right? If the tax rate is greater than 1, if they put like 1.06 or 6, right? If they meant 6%, we should probably divide by 100. We'll take tax rate, divide by equals 100. And that's that combined assignment operator, or little shortcut. You remember these? Nobody's saying yes. We got a couple. Okay, right. So divide by. So you probably gave me 6 instead of 0.06 when I asked for tax rate. So we'll do a little sanity check there. That's probably fine. So then now we can return price times 1 plus the tax rate, right? We should be pretty good. So here's my total price with tax here for the price and the tax rate. Does a little sanity checking. So if I want to default a tax rate, we get to overload our method. So we can have another method with the same name with a different signature. And signature is just a fancy word for the list of parameters. Okay. Now the return type has to match here, but I can make a public static double get total price with tax that just takes a double for price here. Oops, that was not a parentheses. There we go, parentheses. And what this one's going to do is it's going to call the one that takes a tax rate with a default value. So I can return get total price with tax given the price and 0.06. So this is method overloading. So we've overloaded the method, different parameter list. So same name, different parameter list. Okay. So when our program is compiling, Java knows which one to use because it says, oh, this one takes 2 parameters. You gave me one that only takes 1 parameter. You must want the one with 1 parameter. Right, so we want to go use it in our main method somewhere here. If we wanted to like print out get total price with tax given, I don't know, price of 5. It knows, hey, that's the one that takes 1 argument here, just the double. So you can hover over, you can see, here's the little intelligence for it. Or you can print out get total price with tax 5 with a tax rate of, I don't know, let's just say 6 because we're going to screw it up, but we should get the same result out because we're worked around that, right? So now it says, oh, you want the one with 2 arguments. So we've overloaded. It's pretty common practice. And that's how we get around defaults, which gets to be a little bit tricky, especially if you want to have defaults for more than 1 argument. You've got to have a lot of different overloads here, and then the order matters, and life gets a little bit tricky. But we can, right? We've got the code. We can do fun stuff with it. All right, so let's just make sure they give me the same number here. So 530, right, for both of them, 6%, with a zillionth of a penny. Of course, that'll add up. Java's so bad. All computers are really bad at math with floating points. So it's a little embarrassing that we haven't fixed it by now, but apparently that's a really hard problem to solve. Who knew? Um, Arithmetic. So it's a hard problem to solve efficiently, I should say. Easy to solve, but it would take a lot more time, energy, and effort. And the amount of times we do arithmetic with doubles in the processor, it's probably actually zillions. I don't know, is zillion a real number? I don't know what it is. Happens a lot. All right. So we've got other methods here. Again, it's going to be public static for now. We'll get into other ones when we start talking about classes later. That makes sense. Here, the return type, our names here. We can overload. Let's see if we're getting everything we needed here. Oh, exceptions. One more bit with exceptions here, because this is a big pet peeve of mine. When we teach exceptions and show you how to use them initially, people get a little excited here. So if your method is going to throw an exception here, it shouldn't handle it, right? The method, like parse int here, can throw an exception. It doesn't handle it, right? Okay, so if we want to have exceptions here, so we can do our own exceptions. We can say, hey, if the tax rate is greater than, let's do more than 100 here. I'm going to throw a new, and this invalid art. Oh my goodness, where's
Can make it out.
yeah, you can make your own. That's a little harder here. There's invalid attributes. Is that? It's probably not the right one here. Invalid name. So is this argument error? Illegal argument. There it is. I knew there was one here. So illegal argument exception. This is a built-in exception class in the Java lang library. So notice we didn't have to import the lang library. That's just the basic Java language. That one is implicitly imported. So anything in lang we get automatically. If we wanted to use scanner from the utility library, we had to go ask for it here. So we get this one and say, okay, what's our message? So invalid tax rate. It should not be more than a 100% tax rate here. Because we're already, if it's more than that, we're divided by 100. So we can throw an exception. Okay, it's not our job to catch it here. It's the caller's job to catch. Right? Our method's just using this to validate here. Now, the reason why exceptions are really nice here is if the only thing you ever do is system out print line error messages, someone can ignore it. Right? I could print out a message saying that's an invalid tax rate, and someone could just ignore it and keep going. Right? It doesn't make them do anything. It's not forceful. So exceptions are forceful. You did a bad thing, fix it now or crash and be embarrassed. Right? This is our forceful way of doing it. When we get to classes, that's the class's way to communicate a really bad thing happened. I can't continue without you fixing it. Right? The class forces you to do that. And then it also encourages our separation of concerns. Right? Our classes should have nothing to do with console input and output. Right? Because who knows if you're going to use your class in a console program, or if you're a graphical user interface program, or a web application, or a mobile application. Right? The class shouldn't care. It shouldn't need to know what kind of input and output it's dealing with. The class's job is to do its class job. Hold its attributes, have your public functions, public methods, ways to interact with it. Right? So again, throwing exceptions is the forceful way, and then you might not even have a console to look at. No one might even see that error, so it forces them to go and deal with it here. So now we run it. Oh, I don't think we actually call it here, did we? Get total. Oh, we did. Get total price with tax. Here, good. So we don't have to catch the exception, right? But we could catch the exception if we wanted to, right? We could put a try around it. So if we do tax rate of 600, it should crash. Sure, 5,600. Why not? It should crash on us, right? And we get our error message. Illegal argument exception, invalid tax rate. The message, the string we put in here, shows up here in your error, which is nice. Okay? So we could put the try block around it if we wanted. Again, if we're asking the user to input things, that might be more useful. Right? I'm probably not going to hard code in a value that's going to crash my program. That'd be kind of dumb. Right? So again, we'll do the try block. Why not? So try, throw this in here, and then we can catch a illegal argument exception. Illegal argument exception. If you want to print out the exceptions message here, we can just system out the exception dot get message. Right? So whatever message we gave the exception, we can get that back out here This is not very interesting, but now it's not going to crash. We'll get our message invalid tax rate here. It just continues on. There was no loop that was happening here. If we wanted it to keep running, right, we have to put it in a loop and put them back and it'll give me a valid tax rate, these sorts of things here. Now, that all being said, exceptions are slow. So if we can avoid using them, it's better. So if we can do a validation loop, like get something within range here, hey, I need a number between 0 and 100, should use the actual code to do it because exceptions are slow. They happen outside of the main path of execution, and it takes Java a lot longer to handle. Again, it's pretty fast, but it's a bad habit to use them for sorts of flow control that we can just do a bunch of if-else while loops for. Those are going to execute a whole lot faster. So just be in the good habit of doing it that way. All right. And testing. So we don't have classes to test yet here. So far we've done all of our dummy testing with, if we put this in, do we get this back out? If I put this in, do I get this back out? Manually. And you know who's really bad at comparing input and output? See if they match. Yeah, me. It's me. I'm really bad at that. I mean, humans are really bad at that. Have you ever proofread an English paper? You know how many typos you miss all the time? Because you know what it's supposed to say. So as you're looking at it, you're not actually even really looking at it. You're like sort of looking at it and you assume it says the right thing, even though you have a bunch of typos, right? So we're bad at that sort of thing. You know who's really good at comparing, does this thing match another thing? Or what's really good at comparing, does this thing match another thing? One of these computers? Computers are much better at testing than we are, right? So what we're going to do is we're going to write code that tests our code. Sounds a little bit silly, but it's super cool, I promise. And we can get into all these really cool levels of testing. So the smallest, lowest level of testing we can do is at the unit level, 1 unit of code at a time. Essentially, we're going to test one method at a time, right? This unit of code, does this bit of code work? This unit of code. You can get into bigger and bigger tests, take your software engineering class, learn all about that stuff here. Lots of fun ways of different testing here. But unit tests are important to make sure the code does what it's supposed to do, right? Because any code that's worth writing is worth testing, because you want to make sure it does what it's supposed to do. If you don't care if it's right, then why did you write it in the first place, right? You wrote garbage if you don't care if it works, right? That's what ChatGPT gives us. It looks like code. It's probably right. Do we know? No. It's like the Russians, not even Russians anymore, but the old saying, trust but verify. When we were doing a nuclear disarmament, well, trust, we also have to verify. It's a bad example nowadays, sorry. Excuse me. All right, so we're going to test our code. Now, testing is going to be a little awkward here, but we're going to make it work. So we've got a couple of things we can test here. So when I right-click on my class here, we're going to use a testing library because we're going to do code that tests our code here. We're going to use a testing library. So I'm going to say go to test. And IntelliJ says, you don't have any tests. Do you want to make new ones? Yes, please. This is what I would like to have happen. So we're going to make new tests. And it's this error, don't worry too much about it here. You can have other ways of storing code in other organizations here. It's not too big of a deal. We're just going to say, okay, no test routes found. That's fine. What do we want to call it? Week 2 tests. Great. What do we want to use? What library? There's lots of different libraries here. JUnit 5? Great. Let's just go with it here. Now, it's warning us it's not found. So to use code from a library, it has to be added to our project. It's saying it hasn't been added to our project yet. You want to fix it? Yes, let's fix it. So it's like, okay, do you want to go add this module here from org JUnit, Jupyter, Jupyter 581? Sure. JUnit 5, something here. That's probably good here. This is a really cool behind the scenes tool. It's called Maven. So Maven is a build tool that Java uses, Java compilers use to say, you want some code, you want a library, I'll go get it for you. And it will cache it locally and it can go out and find the store where all of these, not an actual store, like the location online where all these things are stored here. You can go and get it. You can download some specific things here, all sorts of fun stuff. And we'll just say, okay, it will do a bunch of cool things for us. We don't have to worry too much about it here, which is really nice. Now, other things we want to do here, like not testing superclasses. I don't worry about packages. We don't need setup, teardown. We can do fancy things with JUnit. At this point, we're not going to. We can get fancier later. Right now, all we want to do is test some of these things here. Like let's test get total price, test get total price. This one, let's test get number within range is going to be hard. So anything that deals with input is going to be hard to test. You can test it. It just is awkward. and we don't have the time and we don't care about it right now. Because our general rule of thumb is going to be any input will happen essentially in main or something part of that main class here. When we start writing classes, classes should have nothing to do with input, right? If you need to give a class a value, it should be an argument, okay? Because you don't want to be tied to a specific console input. Your class is so good and amazing, everyone's going to want to use it in their mobile app or their web app or whatever you want to do, right? Okay. So we're just going to test the ones that put some values in and get some values back out here. So just those two for now are good. We'll say okay, and it's going to generate a bunch of stuff here. So now we have a week 2 test here. Why is it? Okay, so it's red. So now we're going to take the next option. Okay, we already added the module. Now we have to add it to the class path. So all sorts of fancy things in Java. This is go find these classes here and make sure they're included when I hit run. Okay, doing this by hand is obnoxious, but saying add library should take care of that for us. Come on. Did it not? Come on. Add it to the class path. It blinked. It didn't do anything. More actions. No. Add library. Didn't do it. Come on. Let me try on my tests. Really? I want to import. Let's see if it'll just build. Try and just build the whole project here. See if that'll kick it. No? All right, this usually works. I'm a little puzzled at the moment here. What's my other option here? Not testing NG, not JUnit 4. We're using 5. That. Add it. All right, building and then adding it again seemed to have kicked it. It's a little funky. My apologies. But it seems to be working now, which is cool. All right, so we've got our test code here. So we've got 2 functions and they're annotated. This little at sign here is an annotation. It's telling Java something about this method here. So it was generated for us. If we want to add more test methods, we just copy paste. It's just saying, hey, this is a test from this library. Okay. So these tests can go and run when we want to run our tests. So there's a convention we're going to use to test our code. It's just a convention. You don't have to do it this way, but lots of people like this convention, and if everyone follows the convention, it makes life easier for all of us here. So we're going to use this AAA convention. We're going to arrange, we're going to act, and we're going to assert. Okay. So arranging, range is set up the variables we need to test. And then act is call the code we're testing. Code we're testing. And then assert is did we get what we expected? Okay, so just those sections, right? So we're going to arrange, set everything up. We're going to act, we're going to call the code. We're going to assert did we get what we expected? So anytime you look at someone's test who follows this convention, you can look at how they set it up. You can look at what they're testing. You can look at the expected outputs. It just kind of follows this pattern here. So get total price with tax, then I'm going to have a double for the expected total price with tax here. So I expect the result to be what, 5.3, right? With $5 at a 6% tax rate, it should be 5.03. We'll double for tax rate, or no, this is just default. So this is just price, then will equal 5. Okay, and then the code we're testing, we're going to call our method. So then I double for actual total price with tax is get total price with tax here. Get total price with tax. Oh, shoot, that's the test one here. Sorry. No, I need the week 2. Shoot, I got to import week 2. Oh, crap. Week 2. It's in the, because I'm not using packages. Shoot, sorry, I did a lazy thing earlier. Now it's not happy with it. It says test, get total price with tax. Call it test, get total price with tax. Get, oh, sorry, week 2 dot. If I'm using code from another class, another package, another file, I have to tell it, hey, it comes from this one, like we did with the integer. Hey, from the integer class, I want this method. Here's from the week 2 class. Here's my get total price now.
You don't need to import it.
No, so if they're in the same package or the same folder, you don't need to import because and they're all shared. Um, Later, you're supposed to use packages, and I was lazy. The default option doesn't give us packages, so we'll look at that next week when we do more testing. So get total price with tax. We're going to give it the price here. So we gave it the price here. Now we get the actual result back. So what did our code actually calculate here? And we're going to assert. So this is assert, assert, and is it almost? No, assert equal. So assert equal here. We're saying these two things should equal. There's a bunch of different asserts we can use. Most of the time it's equals, right? We want the expected. Oh my goodness. Did it freeze on me? There we go. Expected total price and the actual total price. Now, assert equals, I think we get another option here with doubles here. No, do we not? Shoot, assert. Let's try it and see. So we'll see if we get the right result back out here. Let's get total price with tax overload, I don't know, or tax specified. You can't have two methods with the same name, so I have to change the name of this one here. So this is get total price with tax. This is when we specify the tax. So here we're just going to copy paste. We'll do the exact same thing, but we'll give it a different tax rate here. So if we give it a tax rate of like 10%, that should be 5.5, right? So we'll have a double for tax rate. Oops, sorry, 5. Tax rate is 0.1. So now I can pass it the tax rate here. Go down the line here. Price of tax rate. Now, we've done a little bit of extra testing here because our code for this one actually runs the other method anyway. And the idea with testing is we want to run all of our code. We want to make sure our code actually runs here to test it. So there's officially a metric you can use. It's called code coverage. How much of your code is actually running when your tests run? And ideally, the more code is being tested, the better. Getting to 100% code coverage, getting every line of code running when you write tests, is a little bit tricky. That's an ideal. Maybe a little rainbows and unicorn because it does take time, energy, and effort. But essentially, anytime we have an if or an else, we need to make sure that bit runs, right? So these ones aren't super interesting here. But if I don't test giving a tax rate of more than 1 and make sure it actually divides by 100, I don't have 100% code coverage because this line of code never ran. So I don't know if it works, right? I wrote code and I didn't bother testing it. We did it manually, but again, we should make our unit tests test all of the code to get that 100% code coverage. So that's the ideal here for us. Okay, so let's actually pass in then for our tax rate. Let's do 10 because that will then make sure that that gets divided by 100 to give us an actual 10%, not 10,000 or 1,000% tax, which would be insane, right? Okay. All right, so let's give it a try. So let's go and run these. So you got an option now to just run. We want to run our tests, which is really cool. Yeah, I think the paid version gives you the coverage metrics. Again, I don't have the paid version right now. And now we get a little option here. So we get this one passed here with tax specified. This one did not pass. 5.3 does not match 5.3000001. Oh, crap. The rounding error, right? I don't actually remember here. So let's go Google it. Java JUnit test doubles. I don't want that. Double epsilon. Yeah, that's the one we want here. It's a fuzz factor. Sure. All right, looks like we can just add in another value here. That's what I thought, but it didn't show up for IntelliSense. So when you're comparing doubles here, if you want to allow close enough here, what is that, maximum difference that can be, the delta? Okay, it's even telling me. It's lovely. That's handy. So the delta here, the difference between the two, allowable is some large number here, right? As long as they're within 10 zillionth here, right? We'll call that close enough because we know there's rounding errors here, right? So now when I run my test again, we'll go back and run the test. It should pass, hopefully, thinking about it, and our tests pass. And we feel good that the code we wrote to test our code is saying, yes, it matches. Now, it's possible we still screwed up somewhere, but if you wrote the code and then you tested the code, you should feel pretty confident that it should do what it's supposed to do at that point, right? You feel pretty good about it. Now, the cool thing with tests here, I'll show you, I think I showed you Microsoft's accounting. I already showed you VS Code because it's really cool. They have all sorts of tests running here. So you can go to these commits here, and GitHub, again, they make a lot of money selling these services here. It shows, hey, 21 out of 21 tests passed here. So you can click on that, and you can see all of these different tests here ran and passed. And let's find one that didn't pass here. It used to have, okay, so this one failed somewhere. I don't actually know what it was here. they can do other levels of testings, and you can crazy levels of things here. It's really neat. So these might not be unit tests that are failing, but other things. I don't like a failed to work compile on Linux or something. A published, I'm not sure. But you can click the details. You can see all sorts of interesting stuff about it here. Again, this one's open source, saying, hey, this one failed. We got an exit code 255. We can see what particularly about it here. Not entirely sure. Again, that's beyond the scope of what we want to do right now. But what we can do here, this GitHub Actions, is a pretty common tool, and there's other tools we can buy here. Lots of people sell them. JetBrains will sell you one as well, that allow you to do continuous integration testing. So as code is integrated into your Git repository, it runs tests, which is really cool. So as my code changes in the repository, I can go and test it. And the cool thing with cloud tools is I can have the cloud computers test it. I don't need to run all the tests on my developer machine. Because a large project has lots of tests here. Right? I don't even know what all these different tests are, but they've got a bunch of different tests. And if I was working on a project and I did a couple things and I had to run all these tests, it might take half an hour or whatever happens to be. You probably don't want your developer sitting there for half an hour doing nothing because they're running a bunch of tests because you're paying them a lot of money, right? So we can pawn off a lot of that workload onto cloud tools and make them run the tests, which is really fun. The next cool thing you can do is if you have enough tests and you feel good about your test coverage, you can move from continuous integration to continuous deployment. Hey, if my code passes all the tests, go ahead and deploy it. Again, you got to write a bunch of scripts, all sorts of fun things. DevOps tends to deal with this sort of stuff here, which is a really fun specialty. That was my team at the company I worked at, was the DevOps team. So we could automatically go and then deploy our application to production, depending on what app it was here. Now, a lot of them were web apps, because that's pretty easy. It would go and update that web app in production live here. Because all the tests passed, things were good, we can go and update, push out the latest and greatest version. So I had some buddies who went to work over at Khan Academy. Awesome resource, by the way. If you ever need like videos, it's the only reason I got through calculus was Khan Academy. They're awesome. They would have continuous deployment. So the website, khanacademy.com, would be updated dozens of times a day. So one of the things that tends to make developers more productive is being able to get your feature that you worked on out into production, out into users' hands faster. If you get a request, hey, we need to fix this bug or we need to go add a feature for this, and you work on it for a week, and then it goes somewhere and someone has to test it for a couple days, and it has to go out to some team to go deploy it for a couple days, and then the user's going to test it for a couple days, that's a long cycle, right? And by the time they're like, oh no, I said I wanted this, but it doesn't really do exactly the right thing. Can you tweak it? It's been 2 weeks and you completely forgot what you were doing because you moved on to other projects. And you have to come back and get back into the zone of, okay, what was I working on again here? But if I can make my change in the couple hours I spent doing it and get it out in production the same day and have my user test it the same day, we've reduced that cycle time, which is really cool. Again, all sorts of fun software engineering stuff. I love DevOps, really interesting things here. And maybe we'll have some cool tools in the future where computers can do all that stuff for you here, but it doesn't seem like our robot friends can do that level of stuff now. And if you do let them, sometimes you end up with a $10,000 bill from Amazon. They're like, you used a lot of Amazon resources, please pay us. And you're like, my AI tool did. What did it do? And you don't know what your AI tool did, and then you have to pay a big bill. There's some news articles about this, which is kind of sad. Those sorts of things. So just be careful. So that's our testing. So do we cover control statements, ifs, else, whiles, switches? We did loops. Oh, the other loop we didn't do is a for loop. I'm sorry. That one is a pretty basic loop here. We'll go and do a quick one here. We'll do it at the top here. So in the for loop, we give it three things, right? You can initialize, you give it the test, and you give it the increment or change. It doesn't always have to increment. You can also be decrements. It can be any sorts of changes here. Also say int. Now, most of the time here, right, we like to start things at 0. And this works really well with arrays, right? When you loop through arrays, you can loop through its indexes starting at 0, less than the length of an array. We get to arrays next week here. Say number is less than 10, number plus plus. And really boring array here. But now I've got a number, starts at 0. It is still a pretest loop, right? So it will check, is number less than 10? Is that true? If it's true, the loop runs. Now, it's really easy to make sure these things are true because they're literally next to each other, right? It's possible it doesn't run, though. You could do dumb things and be like, number is 100, number's less than 10, number plus what, and it even warns you, like, it's always false, dummy. you did a bad thing. Right? We get some nice checking here, which is it's just a warning. It'll still let you run it, but it's warning you. And at the end of the loop here, and then it runs the increment, number plus plus, adds one to number, and then it comes back to the test. Do we run the loop? Right? So works the exact same way as a while loop, just saves us a little bit of typing here. And again, you can just print out number, whatever you want here at the end, then we'll print out blast off, right? Or no, you're supposed to count backwards for blast off, right? So let's start at 10. Let's go greater than 0, and then number minus minus, because that's fancy, right? We'll do a little blast off countdown. Now I'll go back and run this one. I'm in my test explorer. Shoot, I don't want to run the tests. So it says week 2 tests here. So I ran the testing. I want to go back to my current file, run that one. There we go. And now we get our blast off countdown. So that's our for loop. Those are pretty basic here. Different than Python for loops. That's okay if you came from Python. Just imagine it's like a while loop with a shortcut. Right. So we did our control statements, we did methods, we overloaded methods, we did our exceptions, we threw new exceptions if we wanted to, and we started testing our code. So we're going to need to test our code for our project. Now, we haven't got the classes yet, so if you don't write it as a class, that's okay. You can still test your methods. I will solve it using a class. You don't have to, it's just an option, yeah.
If we write like wrong testing code, we can get it all like correct.
Yeah. So if you have logic errors in your test code, it will pass wrongly because it incorrectly did what you told it to do, right?
And how we ensure that like our test code is right?
Plan it, look at it. I don't know if there's a good way to make sure your test code is correct. But like with any code, if you know what goes in, you should know what comes out. Because if we don't know that, we have no business writing code because we don't know what's supposed to happen, right? That sort of thing. So it's just a lot of breaking it down. And small unit levels are usually much easier to do. Like, hey, I just want to solve this one small problem here, one small test at a time. Doesn't need to be the whole thing.
So like in your case, we're using hard-coded value.
Yeah. Yeah, so we always test with hard-coded values because that's how I know this goes in, this comes out.
Oh, okay.
Right. I know if I put a 5 in, I should get 5.3 out with a 6% tax rate.
What if like the function is kind of anemic and the value is 6, we should return something else? How do you test that?
Then there would be an if block somewhere, and we'd try it without a 6, and we try it with a 6. We'd have 2 different tests.
Okay.
Yeah, so we would just test all those different paths to make sure we got 100% code coverage.
Thank you.
Yep. All right. You okay so far? All right, cool. Let me go set up the next repository for you for project 1 here. 296, fall 2025, project 1. We got our Java template. Java template. There we go. Private repositories, good. You can do cool stuff with this. You can do like auto testing. If you've seen like auto grader things that will automatically run stuff for you. Problem with those is your input needs to be extremely specific and your output has to be extremely specific. And I find that rather dull. I think it's more interesting when you get to decide what's a good prompt, right? And what the output should look like, those sorts of things, because you don't always get a very specific spec of what you're supposed to build. So you need to learn to be a little bit creative in that process. And it's a lot of work to write them too. So let's go make a new assignment. This will be project 1. So please submit the URL to your repository, add a screenshot of it running to the README, and also include a self-assessment using the rubric in the README. Score yourself. So I'll tell you how you get your points. You're going to go score yourself. Okay? So you'll tell me, hey, I did this part of the rubric, I did this part of the rubric, I did this part of the rubric. Life is good. Okay? So I don't know if you guys noticed, but our state lottery likes to have big billboards around to encourage people to give them money here. And Powerball happens to be a very large jackpot right now because mathematically it's very hard to win. Right? So we're going to let people scratch that gambling itch here, but not lose money. Okay? The only way to win the lottery is to not play. Right? You will lose money when you play. It's designed to do that. Right? That's how the lottery works. That's why we have one because it takes people's money and then supposedly fund schools with it, but we just took the funding from the general budget out because they're like, oh, look at all the lottery money we're putting in here now, which is sad. We're going to build a little Powerball simulator. Powerball simulator. Okay, so what this is going to do is allow people to pretend to play Powerball, so they can lose as much money as they want here and feel like entertained, right? But then they don't actually go and lose a bunch of money. I worked with a lady once. She would buy 2 lottery tickets a day, and that was her retirement plan. She's like, one of these days I'm gonna hit the jackpot and I can retire. And it was really depressing. But
What are the odds?
oh, we can look at it. So Powerball, ball, how to play. Oh my goodness, how to play Powerball. Powerball.net, how to play. Fill out a ticket. Where's my odds? Prizes page. Here's our different prizes. So this is the prize chart. So the odds of winning the jackpot are 1 in 292 million here, right? Because when you play Powerball, there are 5 numbers that come out of a white bucket. So the numbers are mutually exclusive, right? Because they come out of the same bucket. Right? So it's combination 5 out of the 65 numbers. My goodness, I really should remember. 69 numbers? It's been a little while since I looked at it here. Okay. And then there's a 6th red number, or the Powerball number, which comes out of a different bucket. So it can repeat one of the original 5 here. And this is only 1 to 26. Right? So the odds of matching 5 combination 69 plus 1 out of 26 here happens to be 292 million. Now, you might think, hey, I should just go out and buy 292 million tickets and pick every single possible option here. That's a really bad strategy because not only would you have spent $2 per ticket, so you'd be spending almost $600 million, you have to pay taxes on the winnings, right? And it gets taxed a whole lot thanks to our federal tax rate and Michigan tax and things like that. And actually taking the winnings, you don't never get the whole amount, right? If you take the cash prize payout immediately, you get like 80%, 70%. I forget what the actual number is. Most of the time, they want to pay it out in an annuity that says you get some number of dollars every month for the next bunch of years here, which will add up to that amount. The problem is money is worth less every year thanks to inflation. So they can offer that and pay the same fixed number out, but it becomes worth less and less and less and less and less each year, right? So still bad. You're still not going to get your almost $600 million back. And then if someone else also hits the jackpot, you split it. So right off the bat, if someone else wins and 2 people win, you win and someone else wins, you only get half of that. And then you only get the fraction of that half, right? On top of that. And then the 40% taxes you pay to the feds, 4% tax to Michigan, and all sorts of things here. So don't play. Okay. Sorry. Play all you want. It's your money. I can't tell you what to do. But you will lose money playing the lottery. So we're going to let them either pick their own numbers and validate that they picked valid numbers here, right? So you can do a you pick ticket. You tell me, hey, what are your lucky 5 numbers here? Because numbers are obviously lucky, right? Any math majors out there? Are numbers lucky? No. And no one's dual majoring with math? Man, it used to be common at some point. Math is fun sometimes. No, numbers aren't lucky, right? It's all random odds here. So someone having lucky numbers is just dumb. It doesn't work. But sure. So they can pick their own numbers here. We'll validate, make sure they're good here. And then we'll let them know if they won or not. So we'll have to generate a random ticket, which is the winning ticket, and see, did you win? They might win the jackpot. If we run our program 292 million times, they'll probably win the jackpot, right? And we can actually do that. We can run it some number of times until that happens. There's a 1 in 38 chance here. Oh, it must be 38 numbers. Oh, no. This is 38 because you have to not match any of the 5. And the chance of not matching 5 combination 5 of another 5 combination 5, the math gets fun. But it's not just one. There's more than 38, less than 38 Powerballs here. If you win the Powerball here, if that one matches, you get $4. So you doubled your money. Or if you matched 1 white and the Powerball, you got 1 white. So really, it doesn't matter if you match 0 or 1 whites. You still get $4 for matching the Powerball. Then, if you match 2 whites in a Powerball or 3 whites, you get $7. 3 whites in the Powerball or 4 whites, you get $100. 4 whites in the Powerball, 50 grand. 5 whites, $1 million. 5 whites in the Powerball, you get the jackpot. Right? So that's how you can win here. So we're going to have to write a way to test, do these numbers match these numbers, and what winnings did I get out? Right? And every time we have an if or an else if or an else if here, we need to make sure when we're testing our code, we've tested that code path. We have 100% code coverage. Now, the great thing about our tests is we can hard code those numbers. Here's the winning ticket numbers. Here's my ticket numbers. Hey, look, they're a jackpot. because we hard coded it, right? So we can make sure I don't actually need to run my program 292 million times to randomly have a chance of getting a jackpot. We'll just plug it in, right? But we want the numbers to be random. So we can plug in, here's the numbers here, but when we actually run the program, it will generate random ones for the winning ticket, right? But our method that we're going to write to get the winnings out, we'll just take the two sets of numbers, right? Does that make sense? All right. So we're going to do the simulator. So allow the user to buy a single you pick the numbers ticket, validate the numbers entered, no white repeats, all within range, right? All within range, those sorts of things here, right? Or allow them to buy X number of random tickets. Okay, so hey, you want to buy 1,000 random tickets? Great. We'll generate 1,000 random tickets, compare them to the winning ticket, and show you the winnings, right? So what we want to do then is, so I'm sorry, so for this one here, we'll just display the winning ticket numbers and their winnings. For this one here, we're going to display only the winning ticket numbers. So if you bought 1,000 tickets, some of them will match with one Powerball, some of them match with two whites and a Powerball, some of them match with three white, whatever it happens to be. Only show the winning ones. So the idea here, output is really slow, console output. So if we want to run this 292 million times, I'm going to get a lot of tickets. I don't want all 292 million. I only want the ones that won, right? So if I buy 10,000, I buy a million random tickets here, right? I should at some point hit that 5 white matches. Maybe, right? It's not guaranteed. You all know how math works, thankfully. You're smart people here. So just display the winning ticket numbers and the total won or lost here. Now, just a quick tip here. If it shows that the user's winning money repeatedly, like occasionally they can win some money here, but if you run it 3, 4, 5 times and they're always winning money, you've done it wrong. Right? There's something wrong with your code. Right? It should be losing money. The more you play, the more you lose, on average. Right? Occasionally someone wins. Right? That's how they get people to keep playing. And then run all of that in a loop that allows them to keep playing. And at the end, display the total spent, total won, and total lost. Right? So over and over and over, they can pick a single ticket and play, or they can pick 1,000 tickets and do it again, pick another 1,000 tickets, pick another 1,000 tickets, whatever. Keep on going until they're done, until they get bored here, right? Let them do this as much as they want so they're not wasting real money. Okay. And then when they say, okay, I'm finally done here, I'm tired of this, it's not fun anymore, then we'll display the total of how much you spent. You bought 72 million tickets sitting at my computer here, having fun here. You then won whatever number of dollars you won here, and here's your total loss. Yeah.
Although you get the random number.
So did we do random last week? Or did we not do random here? We didn't yet. Okay. So there's a random class here. So we're going to import java.util.random. Thanks for asking. I thought we did that, but I must not have. So to get a random number, let's just do our loop here then. So instead of counting down, we'll do a silly countdown here. Let's print out. So you say you need an instance of random. So we'll say like random. Again, like lots of people use lower random. Some people just say rand here. It doesn't really matter. I type out the whole word random equals a new random. Now, when you create an instance of random, this is where we could go and seed a value. Because remember, it's a pseudo-random number. It's not actually random. It's not cryptographically secure. Right? Don't use this for cryptography. The first rule of cryptography is don't do your own cryptography. Right? We got tons of PhD researchers working on cryptography. You're not going to do better. I'm not going to do better. Let's just be honest. Okay? Maybe if you go and do your PhD in cryptography, then you got a shot at doing better. But no, it's not happening. So pseudo-random numbers look random. And what we get by default here, the random seed value happens to be our clock time. So every time we hit run, it's a different time. It will look like a different set of random numbers. It'll be a different set of random numbers, right? But if you want to fix it, if you want it to always be the same sequence of random numbers, we can give it a seed value and say, start your calculations with this number instead. So we could seed random with a number here. We don't want to do that though, because I want it to be random every time I hit run. That's much more interesting. Okay, so to get a random number, then we just say, after we've made a new instance of random, we say random.nextInt here, and you give it the bounds is usually the easiest one here. So where do you want to start? I want number 1 to 100 here. And now this one I'm pretty sure is exclusive. Yep. So when I hover over next int, I get the IntelliSense. Here's the documentation for it. Someone wrote this as a Java doc comment. Love them for doing it. Please document your libraries. Nothing we do in school will be library worthy. So we're not going to bother. When you go out in the industry and get a real job and go do fun stuff, if you write library code, if you've made it that far, you can figure out how to write Java doc comments. Okay. I'm not going to spend time on it. So the origin is the least value, the upper bound exclusive. Look at that, exclusive. Okay, like most of them are exclusive here. So Python's not, and it drives me crazy. I don't know why. So this would be 1 to 99. If we want 1 to 100, I want 1 to 101 because I'll stop at 100 here. So it's going to be 10 random numbers here. Right? Now, this doesn't check for any duplicates, though. I could get some duplicate values. Right? And white balls in Powerball can't be duplicates. So you have to have some mechanism to make sure if it's duplicate, throw it away. Try again. Right? Or add one. I mean, you could add 1 to it. And I don't care what you do. Some mechanism to make sure that it's not duplicate. But adding 1, it could still be a duplicate of a different one then. So like there's, I don't know, whatever you want to do here. Let's go run our file. So we should get 10 random numbers. And look, we get 10 random numbers. They look pretty random. It started with 67, 10, 81. When I run it again here, let's run our file again. 67, 10, 81. We get 98, 94, 40. Right? It's a different series of random numbers, right? Because it's using our clock time here. So it's mostly random. Okay. Excuse me. All right, so you're going to turn in the website URL. Wow, it's not showing there. It's my screen that's screwing up. That's crazy. So this will be due in 2 weeks then, on the 18th, when class starts. So it's 6 p.m. And then I got to attach a rubric. So give me a second here. So the rubric then. Oh, I forgot to add it. I'm sorry. I forgot to add it here. So we need to include unit tests using the JUnit library for all the methods we write. Write ones that calculate the winnings. So at least the one that calculates the winnings here. You probably have some other methods here. Again, if it's dealing with input, don't worry about it here. Others that don't deal with input, right? So validating their input is between 1 and 69 for the white numbers, not worth testing. Again, we could, it's just not worth our time, right? But making sure that the winnings are calculated correctly is important. Here's the set of winning numbers. Here's another set of numbers. Did I win a jackpot, $1 million, 50 grand, $100, $7, $4, or nothing? Most of the time it's going to be zero, right? Most of the time you win nothing. We want to test that one with 100% code coverage. Code coverage. So every if-else block is tested, right? So did we simulate a jackpot? Did we simulate a 100K winning or 500K winning, 50K winning? Did we simulate the $1 million winning, right? All of those possible outcomes we're going to test with hard-coded numbers to make sure if it randomly happens, the right thing should happen, right? Especially if we're pretending to win money here, right? Our code will be so good we can go sell it to the Powerball people, right? Like, look how good our code is. We definitely are not going to use this to find a winning ticket on our own and go retire somewhere. Right? Yeah. Okay. Does that make sense? Yeah.
In this case, should we go into multiple arrangements within the same unit test?
So you can. So generally, you want to test one at a time. It's a lot of copy paste. So I would do like one test per winning amount. So here's the test for jackpot. Here's a test for winning $1 million. Here's a test for that.
It doesn't need to be all of them in the same block. You can go like one at a time, and then we just take the screenshot of the unit test.
Well, so I just need a screenshot of just the part running here. You'll submit all the code, including the unit test code. You don't need to show outputs of that, screenshots of that. That's okay. So this was a screenshot of it running the simulator part. We should have the unit tests and a shot of the passing unit tests. Unit tests, right? Get rid of the little screenshot of all the green check marks. Life is good, right? You'll feel good about it. Okay. So let me save this, and I can add the rubric.
That's the range of numbers, like it might be like a specific range, it can be whatever you want.
So for Powerball, I'm pretty sure it's 1 to 69 for white numbers. Let me go numbers. Is that it? No, I don't want to join your mailing list. Where's the how to play? I don't actually remember here. Info. Is it info? How to play? Yeah, 1 to 69, Powerball's 1 to 26. All right, that should not have been in my head, but I do this often enough because it entertains me, and then I get to discourage people from playing the lottery, which I find to be useful. You know, the percentage of people who are college educated and play the lottery is a lot less than the percentage of people who play the lottery who aren't college educated. So just by virtue of being here, you probably play it a lot less than other people. But now you've learned something.
So the figures. Right.
Yeah.
So yeah, 5 numbers, 1 to 69, no duplicates, and they're matched in combination, not permutation. So the order doesn't matter. So generally they're sorted.
Okay.
You don't have to go and sort it here, but 1, 2, 3, 4, 5 will match a 5, 4, 3, 2, 1. Okay,
Same.
same thing. Yeah, essentially they get sorted. You don't have to sort, but sure. And then your Powerball's a number 1 to 26 that can be duplicated of the white numbers because it's a different bucket when they actually draw these things out here. Don't worry about the power play options. It's okay. They just want you to spend more money here. Yeah, fill out a ticket, pick your numbers here, or the quick pick is randomly generated. We're doing quick picks here, right? You can pay to enter multiple draw. Oh my goodness, they really want to take your money. Hey, I want to buy this ticket for a month because I really like these numbers. People, come on.
I mean, if they do it, just people buy.
Yeah. Well, Michigan didn't used to have the lottery, and people would go to Ohio to buy lottery tickets. And Michigan was like, "Oh, we're losing money because people are going out of state to play the lottery. They're going to do it anyway. We should get in on it and get the money." Which, I mean, that's a pretty pragmatic approach, right? Um, sure. It's just most people who play really can't afford to play, which is unfortunate. So, that's all right. Okay, so for the rubric, here we go. Did why did I go back here and hit edit? What did I do? Didn't I hit rubric? Oh, I wanted to edit the points. I'm sorry. That's why I hit edit. I forgot what I was doing. I'm a squirrel. This should be, we're going to do 20 points for this one here. Okay. So half the points will be for working. The other half the points will be for testing your code. Okay. So just getting it running is good, but then making sure it does what it's supposed to do, you'll get a much more points here. So let's add a rubric. This is for project 1. Allows users to have self-pick tickets and validates. Okay, so you get 5 points for that, and then allows users to have random tickets or X number random tickets. 5 points there. We'll do 5 more points for keeps looping and grand totals spent, won, and lost. Here we'll do 5. Okay, we'll just do 5 points for tests here then. Tests all the code aside from user input code. Code must test winnings here. I don't know, comparing 2 tickets. Does that make sense? The winnings, like these are my 6 numbers. These are the winning 6 numbers. How much did I win? At least that one here. Ideally, all the code we're going to test. Don't worry about testing user input code. Hey, did you enter number 1 to 69 and validate it? I don't care. That's not interesting here, right? That's fine. However you want to manage not getting duplicates. If it's dealing with user input, that gets trickier. Don't worry too much about it here. We got some options, but I would probably not bother testing that here because dealing with user input just gets hard. We'll look at it next week. It's not the hardest thing in the world. It's just rather verbose. You have to do a bunch of things here. I think it's to be a little annoying. So I think we do that next week. That sound good? All right. So next week we'll talk about classes and arrays, which you don't actually need them, but an array will make your life easier, right? You don't need to use an array for this. You don't need to use classes for this. I will use a class for it when I solve it, and I'll use arrays when I solve it as well. There's some nice shortcuts there. And then this is use it for grading here. Awesome. So that's the 20 points for this one here. So when you do your self-assessment, just tell me, hey, I got the points or I didn't get the points, or it mostly works. I got like 3 out of 5 points. Go for it. I'm happy with partial points here. I tried the test, but I don't think I got it all right or all working here. Give yourself some partial points. Ideally, if it's not working for you, you ask me, and I tell you how to fix it, and you get 100% here. But it always happens. Someone is just like, all I need is a C. That's fine. That's perfectly legitimate. C's get degrees. That's okay. There's this weird pressure for everyone to get A's, and I know scholarships and other nonsense sometimes depend on A's, and everyone likes to complain about grade inflation, but I blame scholarships for that. Like the pressure to have to keep your 3.0 or 3.5 GPA and all that nonsense. Like, I don't know if he did it right. That's my goal here. So if you got trouble, let me know. Happy to hop on and help. We'll work on this for the next 2 weeks. Um, and commit it to GitHub. If you have trouble with that, let me know. It should be working now. The classroom link, there was like a hiccup where the permissions were screwy here. So if you had trouble with week 0, let me know. Project 0, I'll get you straightened out here. We can go from there, okay?